Good evening. I think last part of the lecture was not recorded, so I'll just repeat that. We were discussing sum number 17. Find two numbers whose sum is 15, and when the square of one multiplied by the cube of the other is maximum. Actually, we have taken other number, that is second number as x and first number as y. Okay, so second derivative we obtained at x equal to 9 was negative. So function has maximum at x equal to 9 by second derivative test. Now when x is 9, what is y? It is 6. So what will be the answer? Numbers are 6 and 9. Remember, square of 6 and cube of 9 is to be obtained. Now we discuss sum number 17. Find two numbers. I'm sorry, we have already done that. Sum number 18. Show that amongst rectangles of given area is given means it is constant. The square has the least perimeter. Write down the solution. Start writing. Let x be the length. Let x be the length and y be the breadth of the rectangle. Y be the breadth of the rectangle whose area is a square unit. Whose area is a square unit. Therefore, see on the screen, xy equal to a equal to constant. See, x and y will vary, but their product remains the same. Okay. So we use this condition to express y in terms of x. Now I will write the solution on slate. So y equal to a upon x. Therefore, perimeter. What is perimeter of rectangle? It is 2 times in bracket length plus breadth. So it is 2 times x plus a upon x. Right down. The function to be examined should be denoted by what? F of x. See, there are two types of problems. Direct, indirect. Indirect means word problem. In direct problem, given fx, we first find f dash of x and f double dash of x. In the second step, we solve the equation f dash of x equal to 0. Suppose c is the root of this equation. Then we find f double dash of c. If second derivative is negative, function has maximum at x equal to c. If second derivative is positive at x equal to c, function has local minimum at that point. We repeat the same procedure for other roots if there are any, of which equation f dash of x equal to 0. Now in the second case, that is in word problem, first using given condition, you have to obtain, you have to eliminate one of the two variables because we have to consider univariate function, right? For example, in this case, what is the condition? That area is given. So using this, we expressed one variable y in terms of other. And then find the function which is to be examined for extreme value and denoted by fx. Then same procedure. Okay, good. Now, in this case, fx is obtained. So what is f dash of x? It is 2 into 1 minus a upon x square. Okay, find out f double dash of x also. It is 2 into minus a. What is 1 upon x square? It is x raised to minus 2. Its derivative is minus 2 x raised to minus 3. That is minus 2 upon x cube. So if you simplify this, you get what? That second derivative is nothing but 4a upon x cube. Now solve the equation. F dash of x equal to 0 gives, tell me what does it give? It gives 2 into 1 minus a upon x square equal to 0. That is 1 equal to a upon x square. So x square equal to a, that is x equal to root a. Why plus root a? Because area is greater than 0. Okay. Now find out second derivative at this point. F double dash of root a is nothing but 4a upon root a cube is greater than 0. Therefore, you have to say by second derivative test, function has minimum at x equal to root a. Now at x equal to root a, find out y. So y is a upon x, that is a upon root a, which is nothing but root a. Okay. Therefore, for minimum perimeter, rectangle must be square. That's it. It is better if you write this separately. Hence, amongst rectangles of given area, the square has the least perimeter. Now sum number 19, just listen to the explanation. You can write the solution afterwards. Show that the height of a closed right circular cylinder of given volume and the least surface area is equal to its diameter. Actually, we have solved one sum of this type. In that, cylinder was not closed, it was open at one end. Okay. Let x be the radius of the base, which is a circle, h be the height, and s be the total surface area of the closed right circular cylinder whose volume is v, which is given to be constant. See, show that the height of closed right circular cylinder of given volume is given means it is constant. Okay. Now what is the formula for volume of cylinder? Pi r square h, it is v. So what is h from this? V upon pi r square, that is a upon x square, because we have taken the radius not as r but as x. Okay. And one more thing, v upon pi is again a constant. That is one more reason, in fact. So what is s? It is twice pi xh plus twice pi x square. See, what is total surface area? It is curved surface area plus area of the two bases which are circles, that is why plus 2 pi x square. Now replace h by what? A by x square. Okay. Now if you simplify this, you get s as twice pi a upon x plus twice pi x square. Now what is the next step? Usually I represent this by fx, but they have kept this as s only, so that instead of writing f dash of x, they have written ds dx. No problem. So this is first derivative. It is again differentiated to get the second derivative. Now if you equate first derivative with 0, you get x as what? In fact, you get x cube as what? A upon 2. So what is x? It is a upon 2 raised to 1 by 3, because we have to take cube root on both sides. Now second derivative at this point, you will notice that comes out to be 12 pi, which is greater than 0. So by second derivative test, s is minimum when x equal to a upon 2 raised to 1 by 3. Now when x is a upon 2 raised to 1 by 3, what is h? it comes out to be twice a upon 2 raised to 1 by 3. That is nothing but 2x. So the conclusion is the surface area, total surface area, which is curved surface area plus area of the lower and upper bases, is least when height of the cylinder is nothing but the diameter of the base, that is 2 times radius. Okay, so this is the solution. Okay, now sum number 20. Find the volume of the largest cylinder that can be inscribed in a sphere of radius r centimeter. Let r be the radius and h be the height of the cylinder which is inscribed in a sphere of radius r centimeter. Now from the figure, capital R square is h by 2 square equal to r square. See, what is small r? Small r is the radius of the sphere. And what is capital R? It is radius of the base circle of that cylinder which is inscribed. Now we use this to eliminate capital R. So what is capital R square from this? It is small r square minus h square upon 4. Let V be the volume of the cylinder. What is the formula for volume of the cylinder? V equal to pi r square h. Now some students ask me, sir, why not to eliminate h? See, the reason is simple. Here it is r square. If you find h, then it will be root of, right? But r square is simply capital R square, small r square minus h square by 4, right? So that helps in simplification. Now substitute the value of capital R square. You will notice that V is nothing but this. So find out first derivative. Remember, variable is h. So pi is constant. What is derivative of r square h? It is simply r square because small r is given. What is derivative of h cube? 3h square. This is not difficult. Again, second derivative. So pi into, what is derivative of r square? 0. And what is derivative of h square? 2h. So second derivative comes out to be minus 3 upon 2 pi h. Okay. Equate first derivative with 0. That gives you h equal to positive root because height cannot be negative, greater than 0. So 2r upon root 3. Now at this point, what is the second derivative? Negative. So function, that is volume, is maximum, at which point h equal to 2r upon root 3. Now when h is 2r upon root 3, what is radius of the base circle of that cylinder? It is r square equal to small r square minus this, comes out to be 2r square upon 3. Now what is asked? We are asked to find the volume of the largest cylinder which can be inscribed in the sphere. Now substitute the values. So pi, this is r square, this is h. So we get 4 pi r cube upon 3 root 3 cubic centimeter. Hence the volume of the largest cylinder which can be inscribed in a sphere of radius r is this. See, for CET, you have to remember this as standard descent. Usually I give list of 100 to 150 sums for CET. You have to remember those as standard results. 21st sum, show that y equal to log of 1 plus x minus 2x upon 2 plus x, x greater than minus 1, is an increasing function on its domain. Now why x greater than minus 1? Because then only log of 1 plus x is defined. Now function will be increasing, strictly increasing, if when x is, rather when f dash of x is positive. But they have just said that it is an increasing function. Okay, so find out derivative. What is fx? Fx is log of 1 plus x. Okay, log of 1 plus x minus 2x upon 2 plus x. See, I will simplify this. Let me explain. What is 2x upon 2 plus x? Can I write this as 2 into in bracket 2 plus x minus 4? Is this correct? Check this. Have I written the same numerator? Yes, I have. 4 plus 2x minus 4, that is 2x. Will it help? Of course. So this is 2, if you split numerator, 2 minus 4 upon 2 plus x. Okay. So what is fx finally? Fx is nothing but log of 1 plus x minus 2 plus, because minus minus plus, 4 upon 2 plus x. Now you will ask me, sir, if we differentiate it directly, is it correct? Of course it is correct. But in that case, you will have to use quotient rule. Okay. So this is fx. Now find out f dash of x. Derivative of log is 1 upon into derivative of log of which function? 1 plus x. Its derivative is 1. Why? Because derivative of 1 is 0, but derivative of x is 1. Minus 0. What is derivative of 1 upon 2 plus x? It is minus 1 upon 2 plus x bracket square into derivative of 1 plus x, sorry, 2 plus x, which is nothing but 1. So you need not write 1. Okay. Now find LCM and simplify. So it will be LCM. LCM will be 1 plus x into 2 plus x bracket square. So 2 plus x bracket square minus 4 into 1 plus x. What is difficult? Addition of fractions. Calculus is not difficult. Simplify. So 4 plus 4x plus x square minus 4 minus 4x divided by 1 plus x, 2 plus x bracket square. Okay. Yes. Now you will ask me, sir, what happens if x is 0? In that case, y is simply 0. Okay, so we don't get a function. It is constant, y equal to 0. But for that matter, the locus is x-axis. And therefore we say, do you agree with me? Can this be negative? X square 1 plus x. Now x is greater than minus 1. So 1 plus x cannot be negative. Square is always positive. So what is the conclusion? Therefore I have to say f is increasing. F is increasing on its domain. Right? Let me check the sum. Yes, 22nd. Prove that y equal to 4 sine theta upon 2 plus cos theta minus theta is an increasing function of theta which belongs to closed interval 0 to pi by 2. Okay. So find out derivative. Find out derivative. Tell me what you get. 22nd we are solving. So y is 4 sine theta upon 2 plus cos theta minus theta. So tell me what is dy d theta. I'll give you 2 minutes. Tell me what is derivative. So by quotient rule, what is dy d theta? I'll write directly. This is 2 plus cos theta, okay, denominator, into derivative of numerator. What is derivative of 4 sin theta? Simple, 4 cos theta, minus numerator 4 sin theta into derivative of 2 plus cos theta. What is derivative of 2? 0. What is derivative of cos theta? Minus sin theta, upon denominator square, that is 2 plus cos theta bracket square, minus what is derivative of theta? Derivative of theta with respect to theta is nothing but 1. Okay, now simplify this. So this becomes what? It is 8 cos theta. Okay, so 8 cos theta plus 4 cos square theta, right? Plus 4 sine square theta, denominator as it is 2 plus 2 plus cos theta bracket square minus 1. Now how will you simplify this further? Take 4 common from cos square theta plus sine square theta. I will not show that step. You have to write that in exam. So this is 8 cos theta plus 4 into 1. Why 1? Because if you take 4 common, you get what? You get cos square plus sine square, which is nothing but 1. Okay. Now, denominator as it is. So 2 plus cos theta bracket square, again minus 1. So LCM and so on. So what is important here? Simplification. Calculus has very little role to play. Okay. So this is what? This is 8 cos theta plus 4 minus 2 plus cos theta bracket square. Tell me what you get. So this is 8 cos theta plus 4 minus. Now I will write this directly. So what is square of 2 plus cos theta? It is basically 4 plus 4 cos theta plus cos square theta. So if you subtract, then you get minus 4, then minus 4 cos theta minus cos square theta. What about denominator? Denominator is 2 plus cos theta square. Now, I think 4 gets cancelled. So what remains is 4 cos theta, 8 minus 4, 4. 4 cos theta minus cos square. Okay. So I'll write that. It is 4 cos theta minus cos square theta upon 2 plus cos theta bracket square. Now from numerator, what can be taken common? Cos theta can be taken common. So in bracket 4 minus cos theta divided by 2 plus cos theta bracket square. I hope that this is first derivative. Now what is asked? In which interval? 0 to pi by 2. Okay. So in that interval, cos theta is not negative, right? And 4 minus cos theta is definitely positive. So that product is definitely positive. I'll explain. See, after completing this, you have to say as theta belongs to closed interval 0 to pi by 2. Okay. cos theta is greater than or equal to 0, because in first quadrant minimum value 0, maximum value 1. 4 minus cos theta is definitely, don't say greater than or equal to 0, just say greater than 0, because the maximum value of cos theta is 1. Therefore the product cos theta into 4 minus cos theta is definitely greater than or equal to 0. Also, what about denominator? 2 plus cos theta square is greater than 0. So what is the conclusion? The conclusion is dy d theta is greater than or equal to 0. Okay. For all theta belonging to closed interval 0 pi by 2. Okay. Therefore, y is an increasing function. Increasing function in 0 pi by 2. Right now. We will take one more sum. Actually, this is not from the exercise, but an important one. Write down the sum. Show that the functions like tan x, log x, comma, x minus 1 upon x. See on the screen. X minus 1 upon x do not possess extreme values. Do not possess extreme values. I repeat the sum. Show that the functions like tan x, comma, log x, comma, x minus 1 upon x do not possess extreme values. Now let us write the solution. Let fx equal to tan x. Write down. Let fx equal to tan x. Therefore, f dash of x equal to sec square x. F dash of x equal to sec square x. Therefore, f dash of x equal to 0 has no solution. F dash of x equal to 0 has no solution. Same is the case with functions. Same is the case with functions like log x, comma, x minus 1 upon x. That is, their first derivatives, that is, their first derivatives cannot be 0. Cannot be 0. Therefore, these functions do not possess extreme, that is maximum and minimum values. Maximum and minimum values. So today we will stop here. Tomorrow we will start with miscellaneous sums.